Good day, students. Today I want to talk on the topic titled List of Acid and their Negative Radicals. I told you in our last class that when you have hydrogen that starts a compound, you don't need to name the hydrogen in the course of naming your compound. When you end the statement with acid, it has told us that hydrogen starts the compound. Like when you have HCl, that is hydrogen chloride or hydrochloric acid, and when you have H2SO4, is tetraoxosulfate 6 acid. You don't need to put hydrogen acid, no. H2SO4 is tetraoxosulfate 6 acid. Is that okay? The Latin prefix is 4, and when you are finding the oxidation number of the phosphorus or the sulfur, you now name it as H2SO4, which is tetraoxosulfate 6 acid. Is that okay? Now let's see some negative radical that we have on the board. Okay, we have HClO. This is an acid. It's starting with hydrogen. Sometimes the hydrogen, we have different type of acids. So hydrogen might be at the middle. You might have something like this, NaHCO3. It's an acid also, so far as having hydrogen. Okay. Now, in this case, we are having HClO. The negative radical is ClO. Look at it, you're having negative here. Is ozochlorate 1. How do you get the 1? Let's see. When you're having ClO negative, oxygen has -2, which is constant at the numerator, and you also have Cl plus, there's 1 here, 1 times -2, that's inside, it's not visible, it's constant, equals to -1. Cl 1 times -2, that's -2, equals -1. Cl equals -1 plus 2, take to the other side, equals to 1. That's why you got ozochlorate 1 ion. Okay, the other one we have HClO3. The negative radical is ClO3. ClO3 negative. In this case, I tell you that there is a constant negative on top of this oxygen. You have Cl plus 3 times -2 equals to -1. If there is no negative here, just equate it to 0. Cl 3 times -2, that's -6, equals to -1. Cl equals -1 plus 6 equals to 5. That's why we have this prefix, Latin prefix 3, which is trioxochlorate. Change the chlorine to chlorate when you are naming it, chlorate 5 ion. Why do you say ion? Because it's having a negative radical, whether positive or negative radical, we still call it ion. Okay, the next one, HNO2. HNO2, which is NO2 negative, which is the negative radical. You have NO2 negative. This one we are looking for the oxidation number of the nitrogen. We are naming it, call it nitrate. Okay, N plus 2 times minus 2, which is a constant number, constant radical of the oxygen, equals to minus 1. N minus 4 equals minus 1. N equals minus 1 plus 4 equals to 3. Thus we have dioxonitrate. Di is 2, dioxonitrate 3 ion. Number 4, we have NO3. NO3 negative. We have N plus 3 times constant negative radical of the oxygen, minus 2 equals to minus 1. N minus 6 equals to minus 1. N equals minus 1 plus 6 equals to 5. That's why we have trioxonitrate 5 ion. That will be in this Roman figure. Okay, let's go to number 5. Number 5, what do you have? You have SO3 negative radical, SO3 2 minus, we are in S plus 3 times negative 2, the constant one apart from this one, minus equals to minus 2. S 3 times minus, that's minus 6 equals minus 2. S equals minus 2 plus 6 equals to 4. Let's see, as trioxosulfate. Trioxosulfate 4 ion. Number 6. Number 6, we have SO4 2 minus, we have S plus 4 times minus 2, which is a constant radical on top of the oxygen, equals to this minus 2 now, which is S minus 8. 4 times minus 2 is minus 8 equals minus 2. S equals minus 2 plus 8 equals to 6. Let's see, has been named tetraoxosulfate. Sulfur will change to sulfate when you are naming it with the oxygen. Tetraoxosulfate 6 ion. Why do we put ion? Because it's a radical. Is that okay? Put ion because it's a radical. Number 7, we have CO3 2 minus. I tell you, we're looking for this number of the carbon. C plus 3 times minus 2, which is a constant, equals to this minus 2. C minus 6 equals to minus 2. C equals minus 2 plus 6, which is 4. That's trioxocarbonates 4 ion, because it's a radical. Now the next one is PO3. PO3 3 minus, you're having P plus 3 times minus 2 equals minus 3. P minus 6, 3 times minus 6 equals to minus 3. P equals minus 3 plus 6 equals to 3. That's the value of trioxophosphate 3 ion. Okay, number 9. Number 9. We're having CrO4 2 minus chloride plus 4 times minus 2, which is a constant. Radical on top of the oxygen equals to minus 2. Cr minus 8 equals to minus 2. Cr equals minus 2 plus 8, which is equal to 6. And now naming it to be tetraoxochromate. Is chromine, but when you name it oxygen, call it chromate 6 ion. Okay, 6 ion. Next one, 10 Cr2O7 2 negative. That's these 2 or this. You now write 2 Cr2 come to the front plus 7 times minus 2 equals to minus 2. 2 Cr minus 14 equals to minus 2. 2 Cr equals minus 2 plus 14. 2 Cr equals minus 2 plus 14, that's 12. Variable side by 2. 2 cancel 2. 2 here 1, 2 here 6. Cr equals to 6. And now naming it, we heptaoxo, 2 is di, 7 is heptaoxo 2 dichromate 6 ion, because of this negative radical. It is positive radical, so it's still ion. Number 11, we have MnO4 negative. I have Mn plus 4 times. I told you that oxygen has constant negative 2 minus 2 equals to minus 1. This minus is minus 1. Mn, you don't write it as minus 1. Anytime you see negative standing as minus 1, Mn 4 times minus 2 is minus 8 equals minus 1. Mn equals minus 1 plus 8. Mn equals 7. Manganese. Well, when you're naming it, you call it manganate with oxygen. Tetraoxomanganate 7 ion, because of this radical. Okay, but when you're naming it with acid, you will not call it radical. It will be, let me say we are naming it with this acid now, it will be tetraoxosulfate 6 acid instead of ion. But when you're naming a radical, you just call it ion. But when it is acid, you end it with acid. Okay, this is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.